Good morning, guys. Today's topic is weathering. Your objective is I can define weathering and identify examples of it. Has the Earth always looked the same way it does today? No, that's definitely false. The Earth's surface is always changing, and we've already seen examples of how the Earth's surface, its crust, changes. We've seen this with the different plate boundary interactions. Plates can push against each other in convergent boundaries, pull away from each other in divergent boundaries, or rub past each other in transform boundaries. All three of these interactions create changes on the surface of the Earth. Today we're going to talk about another process that's involved in shaping the way the crust looks. Before we begin, we're going to see what Tim and Moby have to say about the subject of weathering.
Ow. Dear Tim and Moby, what is weathering? From Melissa. Yep, I bet weathering is responsible for those cracks. Weathering is the process that breaks rocks down into fragments and eventually sediments. Soil formation depends on sediments from weathering, and those same bits make up sedimentary rocks. Weathering can even change the Earth's surface over time. Mechanical weathering breaks down rocks without changing their chemical composition. Forces like growing plants, expanding ice, lightning, and mineral crystal growth can all cause mechanical weathering. Plant roots grow into cracks of rock where they can find water and nutrients. When these tree roots get big enough, they'll force the concrete apart. Ice can do the same thing. In cold weather, water freezes and forces rock apart, creating all sorts of pressure. Then it gets warm, and that ice melts, leaving cracks and making the rock weaker. Chemical weathering happens when water, air, or other substances react with the minerals in rocks, soil, and building materials to change their chemical composition. When water reacts with carbon dioxide in the air, it makes carbonic acid. Carbonic acid reacts with the calcite in limestone. Over thousands of years, an entire cave like this can form from chemical weathering. Ah! I'm ready to go. What about you? I think you better find another place to skateboard.
Oh, Tim and Moby. So we just heard from Tim and Moby what weathering is. Weathering is the breakdown of rocks. When rocks break down, they turn into something called sediment. There are two types of weathering we're going to discuss today. Physical, which is also called mechanical weathering, and chemical weathering. Physical weathering is when rocks are actually broken apart by the force of something physical. Some examples of this include frost or ice wedging, like you saw in the video, plant roots, friction, and the impact from other rocks or objects rubbing up against the rock constantly over time, and also the burrowing of animals. Animals can cause rocks to wear away over time. So here's an example of frost wedging. In cold climates, when there is a lot of water that is falling and it's really cold outside, so after it rains and the water freezes, well, when water turns from a liquid to a solid state, it expands. And when it expands, you can see it breaks open the rock under pressure. Plant roots, you can see in the side of this cliff here that the tree is actually growing out of the side and the roots have broken apart the edge of the rocks there. Friction and repeated impact. As this water in the stream flows down this hill here, it's rubbing over top of the rocks, and the force of the water pushing over the rocks causes smaller rocks to flow down with it. And as they flow down the hill, those small rocks hit the larger rocks, and this is happening over and over and over again. And that force of being rubbed upon slowly wears away the rocks. And the burrowing of animals. This is the side of a rocky hillside, and you can see little holes in the side of the cliff where birds have actually burrowed in there. That's going to break away the rock over time. Chemical weathering. Chemical weathering occurs when chemical reactions actually break the bonds that hold rocks together. Rocks are matter, so they're made of atoms that are held together by bonds. These bonds can be broken, which causes the rock to fall apart and form smaller and smaller pieces called sediment. There are a couple of things that can chemically change a rock: water, oxygen, carbon dioxide, some living organisms, and acid rain. Here's the first example of chemical weathering. This rock in Utah is red because of something called oxidation. This is when oxygen combines with the other elements in the rock to form a new substance. That red color is actually a new substance that's being formed on the rock. That new substance is actually iron, which is why it has that red color, which is coming from this reaction out of the sediment. As this reaction occurs, that rock is going to be broken down over time. Water is a huge factor in chemical weathering. It weathers rocks by dissolving minerals that are inside of the rock. And you've learned that, or that you will learn that rocks are made of lots of different minerals. Carbon dioxide. Carbon dioxide dissolves in rainwater and creates something called carbonic acid. And this acid easily weathers limestone and wears it away. You can see in the statue to the left down here that this face is slowly being worn away. It's smoothing out because carbonic acid is dissolving and changing the limestone that the statue is made of. Living organisms. There are some organisms, they're called lichen, that grow on rocks that produce acid, which chemically weather the rock. They're very small. They almost look like little tiny plants, but they're not. And they produce these chemicals that will change the rock. And finally, one that you've probably heard of, acid rain. When we burn fossil fuels, coal, oil, and gas, and those emissions from the fuels get into the atmosphere, they combine with water that's being formed in the clouds, which will fall as rain, and the two of those things combine and form something called acid rain. When acid rain falls on rock surfaces, it changes the surface of the rock very rapidly. And this is an example of chemical weathering. So you can see the difference. Here's the statue back in 1908, and here it is in 1969. You can see that the acid rain, as it's fallen on this statue, has eaten away the face of the statue, and actually the whole body. It's dissolved away what it used to look like. All right, so before we move into partner talk, you can have your notebooks in front of you. You are going to write down what you observe, and you'll be drawing pictures of what you observe. When you're finished watching the demos I'm about to do for you, with your partner, you're going to have 1 minute to have an academic conversation about what type of weathering the demo represented. So here's your expectations. Each partner will speak for 30 seconds. This will be timed. You'll need to speak in complete sentences, and you must cite a fact from your notes that we just went through as evidence for which type of weathering you're speaking about. So for instance, if I was the first partner to speak, I might say something like, I think the demo represented mechanical weathering because the structure is broken down into smaller pieces but not changed chemically into something new. You're going to be practicing this with a partner. Good luck.